Well, it's been a while, but I'm finally making another video, so that's nice. This is my AT&T Trimline Model 210 telephone, which I've had for a few years now, and I think it's made a few appearances in my older videos. Based on some date codes that I've seen inside of the phone, I believe this one was manufactured in the early 90s or so, but the 210 model number goes back to the 80s. And even to this day, you can still get an AT&T branded Trimline, although it's made by a completely different company. So this telephone is comprised of two parts, the base and the handset. The base only has two functions. One is to have the phone go somewhere. And this button right here, the hook switch, can only be hung up when you put it in the base. If you just simply set it down on a desk, it's still off the hook. So you need the base in order to hang the phone up. And the second function is the ringer. Right here is a high, low, and off volume control. And it's new enough that it does not have any bells or anything in it. It is fully electronic. Separate from that, this contains all of the brains that actually make the phone a phone. In fact, these two devices operate completely independent from each other. They just happen to daisy chain off of each other. But if I had a cable that would convert this into a standard RJ11, I could plug it straight into the wall and use it as is. The ringer is just a place to have the ringer and to hang the phone up. So it has a touch tone pad, and it allows you to use either DTMF dialing or pulse dialing. It also has a redial button and a mute button, and here's the aforementioned hook switch. It also has a high-low volume control for the speaker, and last time I took it apart, I forgot to put the actual plastic piece in here, so it's missing. So I was curious, this thing's new enough, it must have a chip or consolidated circuitry in here that does all these functions. So I decided to take it apart and see what goes on inside. So this is what it looks like when you take the back off. There's a little 8-pin chip right there, and I tried looking it up. I can't find any information about it, but that's not actually the important thing. The important thing is under this keypad. So this right here is the MK53731 single number pulse tone switchable dialer, designed and manufactured solely by SGS Thomson, better known as ST. This chip takes all of these various functions, including but not limited to the DTMF encoding, and consolidates it in one integrated circuit. And manufacturers can buy this chip, put it in their telephones, and choose to take advantage of the various different features of this and some of its brethren, which we'll talk about later. This is what I'm going to call, for the purpose of this video, a Trimline on a chip. And we're going to see some more of these later. But for now, we'll look at the MK53731. First, we have single chip DTMF tone and pulse dialer. And related to that, soft switch changes signaling mode from pulse to tone. So mainly it's saying that, you can switch between pulse or tone. Or we can go pulse. And we have recall of last number dialed, up to 28 digits long. So I'll set it over to pulse here, and I can go and redial. So basically you can type up to 28 digits and it will remember them, and you can push redial. Then we have 8 tones per second dialing in tone mode and 10 pulses per second in pulse mode. So that's basically when you're redialing it, that's just explaining the exact timing that goes into the chip spitting the numbers back out. DTMF active until key release. That's just, you can hold it down and it'll go until you let go. Minimum DTMF duration / separation guaranteed. That's more timing related stuff. Pacifier tone provides audible indication of valid key input for non-DTMF key entries. So that one, I don't know what the word pacifier means in this context, but basically if I redial, you'll hear it make a little beep, little 400 or 500 hertz tone that only gets sent to the speaker and not actually on the line. So See if we can do it again. And then the last feature is powered from telephone line, low operating voltage for long loop applications. That's saying that, yeah, you can power it on a phone line. It's a relatively low power chip, which you'd want for such an application. So let's take a look at the pinout. This chip is extremely simple, and it's just if you get the through-hole version, it's a DIP 18. You could also get a surface mount, which adds 2 extra pins that do absolutely nothing. So at the top here on pin 1, we have V+, and related is pin 6, V-. That's your power and ground. This chip, I believe, runs on about 5 volts, plus or minus a little bit. Pin 2 is the mode. That's a high or low signal that controls whether you want to be in pulse mode or touch tone mode, and that is controlled by this switch right here. Then we have C1 through 3, and down here we have C4. And related to that is R1 through R4 over on 16 through 13. So that's the keypad, and it uses a matrix sort of setup, kind of like a lot of old 8-bit computers, how they controlled their keyboards. So this right here is row 1 and 2 and 3 and 4, and likewise column 1 through column 4. And let's say you want to push the 5 key. Well, when you push it, it connects C2 to R2, that to that, and because this is on the second column in the second row, and that's how the chip knows what button you're pushing. And on the topic of the keypad, this does not support the extended DTMF with A, B, C, and D. It only does the numerical numbers. But it has this extra row right here for some chip-specific functions. Most notably is the LND, which is the last number dialed, which is the redial button on here. Next we have OSC1 and OSC2, and that's the oscillator because this thing needs an internal clock signal. Pin 12 is the DTMF output, and that's an audio signal that sends you through all of the passive components to get it ready and able to go on the phone line. Pin 11 is the pacifier tone, which I can confirm is a 500 Hertz square wave. And then we already discussed 4 through 1. 17 is the hook switch, and that's just a high or low signal to detect whether the phone is off the hook or not. And so that'll basically turn everything on or everything off, so it knows. And the last one up here, pin 18, is the pulse output. And the pulse output and DTMF are separate because the pulse actually switches the phone line on and off, so that needs to use a separate circuit than the DTMF, which is literally just an audio signal. So the oscillator, which I'd like to quickly mention, here's the description for it. And what I find really funny about this chip is that it uses what the datasheet describes as a low-cost television color burst crystal with a nominal crystal frequency of 3.579545 megahertz. That is the good old, tried and true NTSC color burst crystal, of which I have very, very many in my collection because I harvest these from AV equipment I find on the side of the road, like VCRs and DVD players. And so I have a lot of these, and I also have a lot of the double harmonic 7.15909, and I have a few of the triple harmonic 14.31818. Now that's not all for the MK537XX series, because they in fact made some other chips. And here, in real life, mind you, I have 2 MK53732 chips. This is exactly the same chip as what we just looked at, but a slightly higher trim level, so to speak. It has the same pinout, the same functions, the same features, but it adds one feature right here. Save another number function, 28 digits long. So not only does this thing have the same redial feature as the last chip, but it also has the ability through a certain combination of button presses to save a number to a single speed dial slot. So that way, after you hang up the phone or perhaps even disconnect it from the phone line, you can get back on the phone and redial your one speed dial number. But wait, there's more. There is in fact a third chip in the MK537XX series, the MK53761. Take a look at the features. We have been downgraded from 28 to 18 digits on the last number dialed. However, we get one major upgrade, 9-number repository. So that's right, there is a speed dial slot for every numeral on the keypad minus the 0 key. So you can save 9 speed dial numbers. Other than that, like with the last chip, it's exactly the same as all of the other ones. The pins are all the same, the other features, the timing, all of that's the same, but you get 9 speed dial locations. Now that is the last chip I can find in the MK537XX series. I haven't stumbled upon any more, and I've kind of looked around. It appears it's just those 3 made by SGS Thomson. But of course there are other manufacturers that make their own trimline on a chip systems.